Hi there, and welcome to another episode of Mr. Carlson's Lab. So over time, I've been approached many times about designing and creating some form of an affordable capacitor leakage tester. Now, capacitors have lots and lots of different tests, and leakage testing can be considered parallel resistance. So we're looking at leakage resistance. So you have ESR, which is equivalent series resistance. This would be looked at as parallel resistance, or a resistor placed in parallel across a capacitor. Just another failure point inside capacitors. They have many. So the capacitor leakage testers lately have been getting really pricey. They've been going $300-400, I find, all over the place. And this is something with an I-tube in it, and something that will source 500 to 600 volts in order to test capacitors. Now, whenever I've been asked to design or create one of these things, I've kind of pushed the question off to the side, and I really don't deal with it because I'm not comfortable with designing and creating anything that's going to source maybe 400, 500, 600 volts nowadays. Really, we live in low voltage times now. And a lot of people really aren't familiar with using high voltages, like way back in the day when everything pretty much had high voltage in it. Even televisions had CRTs with, 21 to sometimes even, higher 1,000 volts in them. So I've spent a lot of time, and I have a huge bucket of capacitors, and I've just done tons and tons of research, and I've come up with a very effective low voltage leakage tester. So you don't need to use high voltage to test the capacitors for leakage. Sounds a little bit too good to be true, right? Well, I'm going to give you some demonstrations and show you how effective this is. And you know what? It'll even find failure points in capacitors that the high voltage testers won't. So the low voltage tester will find capacitor leakage where the high voltage testers just don't even see it. And I'm going to show you that here quite shortly. So I've spent lots and lots of time developing this circuit, and I'm about to release it to everybody so you guys can build these things. And it's an extremely affordable device to build. You can put one of these things together for probably under $20 if you want to build it in its absolute basic form. And that's with the actual bar graph meter on it. If you don't want to build it with a bar graph meter and you want to put this thing together on just a terminal tie strip, like you see in the old point-to-point wired amplifiers, you could probably put something together for under $5. And it's as effective as the Heathkits and Jackson meters and the old Hickok meters that test for leakage. So this is a very handy device to have on your bench, and it will even forecast future failures. And I'm going to show you that as well. That's a really neat feature of this device. It's kind of almost like it has a crystal ball, and that's one of the reasons I used the particular lamp that I did on top of it, and I'll show you that here quite shortly. So anyways, enough of my rambling on. Let's take a look at the device, and I'll give you some examples of how well this thing works. You're going to be very surprised. The two testers that you see on the bench are designed to detect leakage in capacitors. These things don't detect any type of a physical leakage or fluid leakage. These things are designed to detect internal leakage, so basically problems hiding inside the capacitor shell. So, for example, capacitors are supposed to pass AC, but they're supposed to block DC, so they're not supposed to let any direct current through. If a capacitor is passing any direct current, these two devices are designed to detect that problem. And these two devices do that with extremely high voltage. This Heathkit IT11 will source up to 600 volts on these two jacks right here. So when I click this right now into the leakage position, right now there's 600 volts across those two jacks. And that's what's used to detect the leakage in these capacitors. So you can imagine what would happen if, for some reason, you came across those test clips on the other side. So coming across 600 volts from this machine does not feel good. It's very dangerous. If you were to have, say, one hand on one clip and the other hand on the other clip, that could be a very fatal situation. So when you're using a device like this, you have to be extremely careful. If you own one of these things and you're not familiar with it, I strongly suggest that you read the manual and familiarize yourself with this thing, because this thing here will lock in the leakage position. So just say you were to shut this thing off, leave it, and then come back the next day and you forgot that this thing was in the leakage position and there were some probes sitting on your bench. Say you turn on the master switch to your bench or something like that, those probes would be live, and that could be a very, very dangerous situation. The Jackson 591 has a spring-loaded switch. You can see that when I push this, it's putting voltage on these jacks right now, up to 500 volts here on these jacks. And then when I let go of the switch, it automatically removes that and it discharges the capacitor, much like this when you have to manually return this to the discharge position. Now, as I mentioned in the other video, some people like to try to reform capacitors with this particular tester. And if you've seen my previous video, you know my thoughts on reforming. In short, it's not worth it. Capacitors are cheap enough nowadays. If you try to reform a capacitor and you leave it in a piece of equipment and say you go and get yourself a cup of coffee and come back and you'll find your room full of smoke because they just randomly close. They'll just basically turn into shorts or jumpers. So it's really not worth the risk, especially if you like the piece of gear that you're working on a lot. So you're repairing an old signal generator or something like that, and it has a cap in it, and you've successfully reformed it. At any particular point in time, it could turn back into its old grouchy self and basically turn into a jumper. So you don't want that to happen. Again, capacitors are cheap nowadays, and it's not worth the risk, especially if there's something precious on the other side of it, like a power transformer or something like that. So getting back to the leakage test here, you can see that these things are sourcing 600 volts. This one will source up to 600. This will source up to 500 volts to test capacitors. And people have asked me over and over again, Paul, can you design some form of a cheap tester? Because these things are going crazy in prices. I've seen these things selling up to $400 or $500 now for one of these testers with the eye tube in it. So that prompted me to design a device that would test the same way these things test, but at a much lower and safer voltage and get the same results. That's the key. Get the same results and or better results. And that's what I'm always looking for. Now, whenever I design something, I will never release something until it's fully tested. So basically, when I design something, I spend a lot of time with it and make sure that what I'm releasing is 100% legit. And that's why I'm going to show you how this tester works today. And if you're at all interested in building one of these things, all the plans and everything, the circuit board diagrams, the circuit board layout, the schematic diagrams, even the explanation is all on Patreon. It's all right there for you guys if you want to build this thing. So basically, if you wanted to put the circuit board together, everything is sized and scaled. You just print off the document and out of your printer comes the layout. Just that easy. So at any rate, this tester here, this is my prototype right here. That's it right there. And what I'll do here, you can see it has a nice little green glow on the front of it as well. If I get the light out of the way, you can see it has a nice little green lamp on the front, and that will change, and it also has an indicator across the top. So as you can see, I haven't added any writing or anything to the box because this is my very first prototype. And it works very well. Now the circuit board that's inside it, I've got a bunch of circuit boards, and because I've spent so much time with this thing and making sure that I've got a solid device here, the board inside this thing is not the very first board. There have been a bunch of revisions, and the revisions that I've done are basically sizing and things like that, making things all fit. So what I'm going to do now is I'm going to show you some comparison tests between capacitors, and we'll use either this capacitor tester or this one, whatever one fits in the shot better. And what I'll do is I'll give you some comparisons. We'll probably use this one here because this tests to higher voltage, so this technically is going to be more sensitive to the problem. So we're going to see how this thing absolutely destroys this thing for testing capacitors. It's actually kind of embarrassing for the IT11 how badly this thing destroys this. So let's check it out. Just before I get started testing capacitors with both of these testers, I'll briefly go over the functions of this new capacitor tester. So first of all, this is sitting on this roll of wire just to lift it up so everything remains in focus. As you can see, this thing is quite a bit smaller than this tester here, and it runs off of batteries as well, so it's quite a bit safer. Low voltage across these terminals. Not 600. So these are both 3-position switches, so there's a few things under each switch basically. So this is in the off position now, so the unit is off. If I click this to the center, the unit is now on, and the capacitor that would be attached to these 2 probes would be under discharge. So this little yellow LED here will glow as the capacitor is discharging. This places the capacitor that's attached to these 2 probes here under test. So capacitor under test, capacitor discharge, and the entire unit is off, all under one switch. This switch here selects the type of capacitor. So in the upper position like this, it's in paper, poly, or ceramic. When it's in the center, it's in the mica position or the forecast position, and I'll explain the forecast here in just a little bit. Basically what it does is it allows you to tell if the capacitor is going to fail down the road or not. This position here is the electrolytic test position. So that's basically all the functions of this thing here. This will change color. When this is green, the capacitor has gone through its cycle and the test is complete. If this is red, there's excessive leakage. And this is just an indicator of leakage. As this goes down, we can see the capacitor charging. So this is a nice little handy thing to have on the top of the box here. So very much set up like this particular tester here, just basically with modern stuff. So this switch here is doing what this switch is doing. This switch here is doing what this switch is doing. Basically, this switch is a combination of the on-off switch and this all at once. So a lot of things hiding under this one little switch here. So what I'll do is I'll grab some capacitors and let's get testing. The first capacitor that I'm going to test is this newer IC capacitor. So Illinois capacitor, 0.1 microfarad, 104 at 630 volts. So let's test it on this tester first. So I'll put this on the discharge position. Now, as you can see, it's red. This is indicating a lot of leakage. So what we'll do is we'll wait for the capacitor to charge. And this is how fast a newer capacitor should charge on this device at 0.1 microfarad. So there it is. No problems there. So I'll just click this on to discharge. You'll see a little flicker of the LED here. That's how quickly it discharges. And now we'll go over to this one here. So I'll put this capacitor on the test leads here. They're just outside the shot here. The device is so big. As you can see, the leads are attached here. Move that in just a bit. Okay, we'll start off at 3 volts. This is in the paper and mica position, just like it should be. Get these things out of the way so it doesn't touch me. So leakage. And what I'll do is I'll just advance this fast. If the eye closes, so if the shadow angle changes and stays closed, it's a faulty capacitor. If the eye, it can close briefly as it's charging, but if it returns to its open position, that means that the capacitor is okay. So what I'll do is I'll just advance this. So when you see it closing like that, it's just charging the cap. And 600 volts, no problems. So I'll hit discharge. And no problems with this capacitor at all. So it shows good on both devices here. So what I'm going to do is turn that back down to 3 volts. And this is safely discharged. I'll just remove this from the clips. So let's see, let's try this one here. So here's another 0.1 microfarad, different style of capacitor. So again, I'll attach it to the lead here of the newer tester. And again, we're in the paper, poly, and ceramic setting. We can also do ceramics on the mica setting because ceramics are such a low leakage style capacitor. I'll get into more of this here in just a little bit, but basically the upper position is paper and poly and ceramic. Can be used for, paper and oil and things like that as well. All right, so right now we're on the discharge position. So here we go. So no problems with that capacitor as well. I'll just move that over to the Heathkit checker here. Got to be so careful around these little short leads that I don't rub up against this. That is not pleasant when that's at 600 volts. So in the leakage position, no problems. Back down there, no problems with that capacitor either. So I'll go grab a few other capacitors and I'll be right back. Let's test a famous Bumblebee style capacitor. Audio guys really like these things. So this came out of a piece of Hewlett-Packard test equipment. It had a nice little nylon strap around it with a little stud that stuck out of the bottom, and they would screw the stud onto the chassis and hold the capacitor above the chassis in place. They really did such a nice job on assembling the HP gear way back in the day. It's, so meticulous. But that doesn't mean that the capacitor's good. So this is 104, so this is 0.1 microfarad, just like the other capacitors, and rated at 400 volts. So let's test it on the new capacitor tester first. So here we go. Now, if you recall, the other 0.1 microfarad capacitor, how fast it moved down, the brand new ones. And you can see here that already it should probably start moving down. And it isn't. So you can see that, this capacitor is very leaky. And if this was left on the clips for an extremely long time, it may move down a light or two, something like that. But as you can see right now, it's, very, very leaky. There's no movement at all. Now, just because a capacitor is leaky doesn't mean that it isn't charging. It will charge, but self-drain very fast. And you'll see that this will hold a charge here. You'll see this little flash when I click it onto discharge. See that little flash there? So that's indicating that it did charge. But it's just excessively leaky. There's excessive resistance present within this device. So now what I'm going to do is take this and test this same capacitor on this tester here, and we'll see how many volts it takes to make this thing indicate that this capacitor is faulty. So we'll start off at 3 volts right here, and I'll make sure that this thing is out of the way so I don't touch it. Leakage, 3 volts, 6, 10, 15, 25 volts, 50 volts, 100 volts, and now we're at 150 volts, and now it's starting to show excessive leakage. Now, keep in mind that this is just battery voltage across here, and it's showing that that capacitor is bad with battery voltage, whereas this has to put 150 volts across the device. Now, the shadow angle is closed, and if you leave this hooked up for a long period of time, it may open. Oh, you can see it's actually trying to open now. So it may open, and it's the same thing with this device here. If you leave it attached for an extremely long period of time, it'll most likely start to count down just a little bit, as you can see this one here, but you know how long it took for that to happen. It should be instantly open, so we would know that this capacitor is faulty. But it took 150 volts to show that with this tester, whereas this did this, and it shows it's very bad. There's even no movement here whatsoever with battery voltage. So what's that telling us? We don't need high voltage to indicate leakage. I'll go grab another capacitor. Let's test a brand new 0.01 microfarad capacitor. And I'll show you the forecast feature on this as well. So this is rated at 0.01 microfarad, 630 volts, so 103K here. Now watch how quickly the display moves down with a brand new capacitor of this value. So there's an example of a really good brand new capacitor. Now what I'm going to do is I'll leave this hooked up and I'll show you the forecast feature. So we'll do the test again. And what I'm going to do is click this into the Mica or forecast, and this should stay green. If it goes red again and starts to count back up, that would tell me that there still is leakage in there, but it would be minor leakage. And it probably wouldn't be safe to be using in any circuit. So as you can see, it's staying green, no problems with the forecast. So what I'll do now is remove this, and I'll grab another brand spanking new capacitor here. This one says Argon on it. This came right off a card, brand spanking new, 0.01 microfarad capacitor at 600 working volts DC. So let's test this one. I'll put this back into the first position here. So again, we're on the paper and poly and ceramic setting with this switch here. So here we go. So you remember how quickly the other one moved down. You can see with this one here how it's lingering quite a bit longer. So already we kind of have an idea that, this thing is most likely going to be leaky, right? So just say you didn't have that other capacitor to compare this one to, and you're thinking, oh, it's counting down. Maybe it's okay because, chances are that green LED is going to come on any moment here, and it's going to appear to be okay. So now what we want to do is we want to forecast to see whether this capacitor is actually going to be okay to be putting in circuit. So we want to know if there is any kind of leakage happening within there that we just can't see. So if I click this onto forecast and this goes red again and starts to count back up, we know instantly that this capacitor would not be suitable for service. As you can see, the capacitor is leaky, and we wouldn't want to use that. So again, I'll grab that other capacitor. So this is the other brand new capacitor. I'll put this back up here and click on discharge. So again, I'll just show you this with the forecast. Put that here. It'll count down fast. See how fast that counts down? Now I'll instantly click this to forecast and it should stay green. We know there is no problems with that capacitor. So this is doing way more than this capacitor tester already. And if that isn't good enough, turns right up to 600 volts, hit leakage. This tells us that there's no problems with this capacitor. Let's click this onto discharge and show you. So you would have missed this faulty component with this tester, whereas this one shows that it's faulty at low voltage. This is 600 volts, and it's telling us that this is okay. Let's test another capacitor. Let's test some Mica capacitors. First up is this Sangamo or Sangamo capacitor. These are rated for well over 1,000 volts, so I can pretty much just test this right at the 600 volt mark. We'll test it on this one first here though. It's on the Mica position, Mica and forecast. Here we go. And as we can see, that's moving pretty fast. No problems with that one. So, move this over to the Heathkit and then we'll compare it to the Heathkit. And that out of the way. Just turn this right up to 600 volts. No problems. Eye remains open. No problems with that capacitor. Let's try this Aerovox 1445 series. You see that there? Test it on this one here first. Look at that one move, no problems. And let's test this on the Leakage tester. Let's move that out of the way. Again, up to 600 volts. Leakage, no problems. Again, we're on the paper and mica. 600 volts here, turn that rate down. Even though it's on discharge, I always like to turn this down first before I handle anything, just as an extra precaution. And here's another of the same capacitor. This is another 1445 series, Aerovox. Test it on this one first. That is definitely leaky. They're all the same value. Look at that. Definitely a leaky capacitor there. Wouldn't want to be using that one in circuit. Okay. Let's test it on this one. Keep in mind that this is testing this with low voltage. Let's test it on this one up at 600 volts. Move that out of the way. Paper and mica. We'll move this right up to 600 volts. No problems. This would have completely missed that faulty component. And the component is definitely faulty because it was removed out of a piece of gear that was very badly affected by it. Try it again. Nothing. No matter where we move this, nothing. Hit discharge. So this one here has 7012 written on it. I'll just move this down. Move this back in here. So I'll just move this out of the clips. So this one here has 7012 written on it, as you can see right there. Into the shot. All right. So what I'll do is I'll put this back on here. Let that sit for just a moment, because sometimes there's a bit of soaking that happens. I'll get into that in the future. All right, let's try this out. Look at that. That is one unhappy device. So as you can see, now it's not even moving. Well, it's moving a little bit. It'll probably settle off to the same area again, probably due to some soaking. And again, we'll test the same one on this device here, Leakage. That out of the way, right up to 600 volts. This shows no problems whatsoever. Let's try it on the Jackson tester as well. Let's try that Mica capacitor with the Jackson Model 591. So this operates a little bit differently. The eye remains closed when the button is out. So basically it's in discharge right now. If I press the button in, you can see the eye opens. So it's indicating that it's trying to test. If the eye was to remain closed when I press this button, there would obviously be excessive leakage, just like it says. Closed shadow indicates excessive leakage right at the top there. So to give you an example, we'll say put it to 20 volts. I wouldn't want to go much higher than that because the next step is 100 volts. What I'll do is I'll just short the two leads out here and you'll see that there's excessive leakage. The eye doesn't open, whereas if I move these apart again, no problems. Eye opens. So let's test this capacitor. This is the faulty Mica capacitor with the Jackson. So just put this here and here. Set this off to the side like that. Test it at 500 volts, its maximum voltage, and here we go. No problems. This doesn't see the issue as well. So I'll just let that sit for just a moment before I put it on this tester here. And we'll test this one again with this tester here. And as you can see, it's definitely faulty. So both of the testers missed the issue. Now I could let this thing sit on this for a very long period of time. I have already. And it'll only go down to, maybe 3 lights, 4 absolute maximum after an extremely long time. That's it. So again, low voltage indicates the leakage. High voltage completely misses it. Let's test an electrolytic. Let's test this older can-style electrolytic capacitor. So there's 4 capacitors in this can. All of those capacitors are rated at 450 volts. You can see here that we have 40, 20, 20, and 10 microfarad. This is the legend, so you can see we have a half moon beside the 40. So if we go on the bottom here, there's the half moon. This is the 40 microfarad lug. You see we have a square here, triangle here, and no marking here. Square here, triangle here, and no marking here. That's how you identify which capacitor is which lug on the bottom of the can. So this is on the electrolytic setting here. Just attach this up. Black lead goes to the can. And we'll attach this to the square. Click it to test. Now this is quite a bit more sensitive than the Heathkit IT11. The Heathkit IT11 will indicate a good capacitor at about 15 microamps of leakage. This is a little bit more stingy. I've set this down to 5 microamps. So a little bit more picky with capacitors here. And that can be adjusted inside. You can set it lower down to a microamp if you like, or set it right up to 15 like the Heathkit IT11, whatever makes you happy. This here is the discharge LED, so you can see that takes a little bit of time to discharge. High brightness LED. And that just drains off the capacitor. And we could just test all the other sections like that as well. So this is handy for all sorts of capacitors. Let's grab a modern electrolytic cap here. Very good capacitor. Rubicon LLE series, high life. Very, very good capacitors. 450 volts, 22 microfarad is the rating. So let's test this one out. Rubicon makes great capacitors. Look at that. No problems whatsoever. And that's how this thing tests electrolytic capacitors. Just that easy. So you're working on a piece of equipment and you run across a capacitor. It says Sprague and it's got yellow writing. Well, from experience, we know that Sprague capacitors with yellow writing are paper capacitors and they're very leaky. And you work on a piece of equipment, you run across a Sprague capacitor that's got red writing on it. You know that it's a dye-film capacitor, and they are just slightly leaky, but way, way, way better than this capacitor. At any rate, they should both be changed out. So then you work on a piece of equipment, you come across this thing. What is this? It's got white writing on it. We don't know what type of capacitor this is. Is it okay to leave in circuit? Is it maybe a poly-style capacitor? We really want to find out. So let's use this box to determine what this is without breaking into this capacitor. So what I'll do is I'll just attach the leads up right now. The unit's off, but attach the leads. Get these out of the way. This is on the paper, ceramic, and poly style capacitor setting. Let's move those out of the way. All right, let's see what happens with this capacitor. So this is 0.15 microfarad. We know how a 0.1 microfarad capacitor looks on this tester. It takes a small amount of time for the capacitor to charge. And as we can see, the lights are Slowly coming down here. They're moving at a pretty good rate. So, move down at a fairly good rate. So let's use the forecast position to see if there's any hiding leakage inside this thing beyond this point. So this will really tell us whether it's a paper style capacitor or a poly capacitor. Again, if this changes at all, well, there we see it. If it changes at all, this is a higher value capacitor, so, the movement is just a little bit slower. You can see it's backing up again. So there is leakage inside that capacitor. As you can see, it's climbing back up the scale. So that would tell us that this thing is definitely going to fail down the road, and we would want this thing out of there. Look at how fast it's climbing back up. So right then and there, we know that this capacitor would have to go, even though it went down at a relatively good rate. Using the forecast, we can definitely see that, it's definitely got internal leakage. It's resistive. It's on a path to decay. Let's put it that way. So, click it back up to here and click discharge. So let's take a look at another capacitor here. Let's take a look at this Goodall capacitor. Let's see what happens with this one here. I'll just get rid of this one and attach the Goodall. And here we go. Let's try this one out. Let's get this one out of the way. This is an older style capacitor as well. We really don't know what's inside this thing. This one's a little higher rating than the other one. This one's 0.2 microfarad. Positive or negative 10%, which is pretty standard for the capacitors way back then. So the other one was 0.15. We saw how long it took for it to start to move. This one is 0.2, and it's moving at a fair clip as well. So in order to omit some of the delay when this changes from green, we'll just do this really quick. And we'll see if the color changes, and if it doesn't change, we know that this is most likely a poly-style capacitor. And as you can see, this capacitor here has very, very low internal leakage. So I would consider this some form of a poly-style capacitor inside, or something that they've used back in the day that exhibits extremely low leakage. You can see that the scale is not climbing back up again. So I would feel comfortable leaving this thing behind in a circuit. So the Goodall capacitor really does stand up to its name in this case. Here are just a few other examples of some of my creations that I've released up on Patreon, and there's a whole lot more coming. I'm just getting started. So this thing is a component tracer, so basically a curve and signature tracer with a very low distortion audio signal source. So for example, say you have a power supply or something that you don't have any schematics for and you want to find the problem on the circuit board. This will help you very quickly locate the problems. And I give some examples in some videos up on Patreon of how to use this device. I very quickly find the problem on a circuit board from a drive with this little thing. Very, very useful device. This can be used for testing diodes and transistors, and it can be used for all sorts of different things. So it's a converted older oscilloscope. There's a bunch of circuit boards in here. All the layouts, schematics, component maps, everything is all released on Patreon. There's quite a few people up there building these things right now. So this is the capacitor tester that we just looked at. All the files for this have been released up there, as well as circuit board layouts and things like that as well. This is the Carlson Super Probe, a very, very sensitive non-contact style probe. All the layouts, lots of files on this thing, all the layouts, component maps, circuit board, schematics, everything for the main amplifier unit and for the probe head have all been released on Patreon. This here is the capacitor foil side tester. Everything has been released on that as well, circuit board layouts and everything. And there's so much more to come. I'm just getting started. So definitely come up there and check it out. There's lots of great people there. Everybody's very friendly. You'll really enjoy it. So I'll put the link just below this video in the description, and I'll also put it right at the top of the comments section as well. So I'll pin it at the top of the comments section. So feel free to click on the link and come on over and check it out. Thanks for stopping by the lab today. Hope you enjoyed this demonstration of the capacitor leakage tester. I have many more inventions that I'm going to be sharing on Patreon here quite shortly. Lots and lots of files full of them. This capacitor leakage tester was somewhat of a recent thing. I've been approached so many times about this, I figured that I better sit down and try to develop something, at least something that would be beneficial, especially since the capacitor leakage tester prices have just gone absolutely through the roof. I'm also working on some restoration videos for YouTube right here. I've got lots of restoration and repair videos coming for vacuum tube and solid state stuff alike. Often I get the question, Paul, how come there's such a delay between your videos? Well, these restorations that I do here take an incredible amount of time to do. Just the restoration and the videography alone is all time consuming, and I'm making videos for here and for Patreon, and of course I have my regular daily life I have to live as well, so I'm a pretty busy fella. So as soon as I get them done, they're basically into editing and produced and put out just as fast as I can. So I appreciate your patience in waiting for these videos. As I say, I've got some really neat restoration videos coming. Recently, I've purchased some very interesting pieces of test gear, probably some things that you've never seen before. So I hope you enjoyed this video. Check out Patreon. The capacitor tester will be there with all the files, and the printed circuit board is ready to be printed off. And if you're just into learning about electronics in a different and very effective way, head on over there and check it out as well. There's lots of people's entries in the community section, so you can see what people are adding to the Patreon site. All right, take care. Bye for now.